So today is lesson 4.7 in your algebra book. We're going to be talking about equivalent formulas. So our big idea, if a formula gives a first variable in terms of a second variable, it may be possible to transform the formula to give the second variable in terms of the first. Now that's a really wordy big idea. Basically, we're going to be working towards equations that have more than one variable in it and solving for either one of them, meaning getting it by itself. X equals everything else, y equals everything else. So we're used to solving equations that just have one variable, we get it by itself, and it equals a number. Well, it isn't always going to equal a number if there's another variable. It could equal an expression on the other side. So that's what we're working towards, is what does it look like to solve for a variable when it's not going to equal just a single numerical answer because there's another variable in this equation. So starting off with our definition, equivalent formulas. So we can say formulas are equivalent if every pair of values satisfies the equation. Now when we say every pair of values, we're talking about coordinates, our x, y. Okay, if we plug in any combination of x and y into different formulas, they're still going to give us the same answer. So now example number 1. First two we'll run through very quick just to reiterate some of the things we know about solving an equation. And then we're going to work towards these equations that have multiple variables, sometimes even 3. And what do they look like if we're solving for any single one of those variables? So just the basics. When we solve here for y, we always talk about getting y by itself. So it says y equals everything else. So in order to do that, we're going to be moving all of these numbers away from it. Now, eventually, they're not always going to be numbers that we're moving. It could be letters that we're moving. And that's why we're going to start with the basics here. So every property that we use to isolate this variable with numbers, we're going to do the same thing with variables in just a bit. So since I want to move this 7, since it says plus 7, I'm going to minus 7 on both sides. These cancel. So now I just have 2y, and then the 19 minus the 7 is 12. And now when I see multiplication, now it's important. I know everybody knows, they see this, they go, oh, I'll add a divide. But we need to think about why we're doing it, because when we get to the variables, it needs to make sense. So this says 2 times y. So in order to reverse that, we're going to divide, and that eliminates the 2, because anything divided by itself is just 1. So this is a 1y, and it equals 6. Okay, so when we wanted to move this, we subtracted it to get it to 0. When we wanted to move this, we divided it. All right, if we have the same variable on both sides, we just finished talking about how we're going to eliminate one of them, ideally the smaller one, which keeps everything positive. So since we have a y on both sides, we're going to cancel out the smaller one, leaving just 10. So I have 3y plus 25. Now I've got my standard looking equation. I want to get y by itself. A plus 25, I minus it, leaving me just the 3y. So even if it's on the right side, I'm moving everything away from it. 10 minus 25 is negative 15. This is times, so I divide. Anything divided by itself is 1. And over here I get negative 5. So using those same properties now, we're going to examine this equation that has 2 variables that we're going to have to deal with. So we're solving for y. So we're not trying to get x by itself, we're trying to get y by itself. Both of these, y was equal to just a single number. It's not going to happen here because I have 2 variables unless I could plug in a number for that x. But in this situation, they're not telling me what x equals. Okay, so we're just going to get y by itself. So when it says solve for y, that means get it by itself. Isolate it. And that's what you'll see sometimes in a textbook. They'll say isolate the variable. So as I come over here, I want to get y by itself. Well, think about what we did over here. The last thing we did was this division to get rid of the 2. So that's still the last thing we're going to do. The last thing I did was divide by the 3 to get rid of it. So this is the term that I want to eliminate. Okay, I need to move it. I want it to end up on the other side of the equation. So in order for that to happen, just like if this was just a positive 5, forget the x for a second, I would minus 5 to get rid of it, to get it to a 0. Remember, this minus goes with the 2 as a negative. So this is a positive 5, I would minus it. So I can't just write minus 5, though, because that doesn't eliminate this term. To get this term to 0, I need to minus a 5x. And all our properties, of course, say that we must do it on both sides of the equation to keep this equivalent. So these are gone. All right, so we eliminated the 5x, leaving us a negative 2y. And now here's the key. So before, if this was just a 5, you can do 50 minus 5 and you can get an answer. But I can't do 50 minus 5x and get a single answer. So I'm just going to leave it like this. This is 50 minus 5x. So don't tell me that it's 45x, because it's not. That would be 50x minus 5x, not 50 minus 5x. So there's nothing I can do here. It's just an expression because these are not like terms. I can't put them together. I have a 50, and then I have this term that has the x in it. So it stays just like this. If you like to put the x up front, you could. So you could write this as negative 5x plus 50, but it's not really crucial for you to do that. You don't have to do that. Now I want to get y by itself. So this says times negative 2. I'm going to divide by negative 2. Now, this whole side is going to get divided by negative 2, leaving me just y by itself. And now we kind of need to deal with this side. So you technically could leave it just like this, and you could write 50 minus 5x over negative 2. It's not incorrect. Not fully simplified, though, either. So what you can do is you want to look and see, do either one of these terms divide by 2 nicely? If they don't, then this is just fine to leave like this. But if they do, then you actually do want to simplify it. And 50 divided by 2 is a nice number. So what I'm going to do is I'm going to split this up. We talked about this actually earlier in the algebra book. You can write this as 2 separate fractions. So 50 over negative 2. And then you could write minus negative. So instead of divided by negative 2, well, let's just write it out so we're not confused. So minus 5x over negative 2. Now the reason that we did that, to split that whole thing up, is because I can actually divide this. So y equals 50 divided by negative 2 is negative 25. And this does not divide nicely. So I'm going to leave this as a fraction, the 5/2. Now it is minus a negative. You can consider this whole thing negative because of the negative 2. So really it's just all going to become a plus. The 2 negatives make a positive. And you can leave it as 5x over 2, but you can also write it as 5/2 x. You can bring the x next to it. And if you had rearranged this earlier, you could put the x in front. We're kind of used to that term coming first. So if we want to rearrange this and put the 5/2 x first, and then the negative 25 we would write as a minus 25. So if you wanted to start by putting that x up front up here, then it saves you something to do later. But it's not incorrect if you don't put that term up front. But traditionally, we're always going to move that x up front. All right, so at first you might be like, whoa, that was a lot. That was kind of new, kind of different. So let's practice a bunch with this. So if we go to example number 2, we're solving for w. So that means get w by itself, or isolate w. So here's w. Last thing we're going to do is get rid of the 2 that's attached to it. So first thing I'm going to do is get rid of this. I want this to say w equals everything else. So in order to get rid of this, again, pretend it's just a 2 for a second, you would minus 2. So it's a 2L. You're going to minus 2L on both sides. So it eliminates it here. And so we're already a lot closer to having w isolated. But again, over here, these are not like terms. They don't have the same variable. I can't do anything with it. And so I'm simply just going to leave it as p minus 2L. I've actually almost solved for w because all that's left is this 2. So I'm going to divide by that 2 to get rid of it. This whole thing gets divided. And now w is by itself. You can split this into 2 separate fractions. So p over 2 minus 2L over 2. And you can see why I would do that is because these are going to cancel each other. So that's just going to become a minus L. So I'm going to write that right under it. Those 2's canceled, or 2 divided by 2 is just 1L. And this right here, you could leave it as p over 2. You can remember there's always a coefficient of 1. So just like up here, instead of leaving the x in the top of our fraction, you can just put it next to it. So it's a fraction times it. So this is really like a 1/2 p, but it's the same thing as p over 2. And we have solved for w. Now you may ask, well, what's the point of this? Why am I doing this? Well, there's definitely going to be some times in the future that you're going to see that this is necessary. For now, we're just practicing the skill of isolating that variable and solving for it. But what's nice is, so if we wanted to know what p was equal to, and it's perimeter in this case, and we have the length and the width, we plug them in for length and width, we do the math, p equals our answer. But let's say you were given perimeter and you were given length and you wanted to solve for w, you'd plug in and then you'd have to work this equation out to get your answer for what is the width. Whereas in this equation where it's already solved for w, if you're given perimeter and you're given length, it just works itself out and that equals whatever you're looking for, the width in this case. So if you've already solved for that variable, when you plug everything in, it just works itself out and it gives you a nice number. So that's kind of the point of this. So example number 3, volume equals 1/3 pi r squared times the height. So we want to solve for h. We want to get h by itself. So if you take a quick glance, it looks like we got to move a lot of stuff. But if you look, they're all being multiplied. 1/3 times pi times r squared times h. We're multiplying everything together. So since they're all being multiplied, they're all showing the same property or the same operation, we can actually move them all at once. You don't have to move them one at a time if they're all doing the same thing. So they're all being multiplied. So to get rid of them, I'm dividing. So what do I want to go away? I want the 1/3 to go away. I want the pi to go away. I want the r squared to go away. I want to leave h right where it's at. Okay, so on this side, I'm going to divide the v by the same thing. So what happens? These all divide by themselves and cancel, leaving me just h. And so what does h equal? Just all of this. V over 1/3 pi r squared. Now it looks weird to have a fraction inside of a fraction, right? Doesn't mean it's wrong. It's not incorrect, but it does look weird. So right now this says divided by 1/3, which remember is the same as times the reciprocal, 3/1. So if I times v by 3/1, I'd end up with the 3 up top. So you can translate this down. What this does is it ends up flipping because you're dividing by it, and the 3/1 puts the 3 up top. So dividing by 1/3 is like multiplying by 3/1. So you actually end up with a 3v over pi r squared equals h. But either one of these are fine. So if you don't quite get that jump right there, that's okay. Now let's try this again, because there is often a different way to get to this same answer. So a lot of times the first step that a textbook will want you to do, or just in general that sometimes is the best practice to do, is always to eliminate a fraction if you can. So how do I get rid of a fraction when it's being multiplied? Well, you multiply by the reciprocal. So I'm going to multiply both sides by 3/1 as my first step here, which will just eliminate this. So 3/1 is like 3 times v. It's going to give me 3v. And what I've done on this side is just eliminated the fraction. So these go away. That was the whole point. That's why I multiplied by the reciprocal, so it goes away. I'm left with pi r squared times the height. And again, I'm trying to get height by itself, so I'm going to divide by pi r squared. You can do them one at a time, but let's just do it all at once so that they go away. So they're gone, leaving me just h equals 3v over pi r squared. And I have solved for h. You'll notice these are exactly the same. So most of the time you're going to see steps shown like this where they're going to eliminate the fraction first, but you don't have to. You could divide by it. Dividing by the fraction is the same as multiplying by the reciprocal, which is what we did up here in one separate step. All right, so as we move to the back now, and we look at these two examples, they both have fractions. So we're going to kind of practice this multiplying by the reciprocal as part of our process here. But first of all, I'm trying to solve for c, so I want this to say c equals. The last thing I'm going to do is attack the coefficient that's attached to this variable. So I have this plus 32. If I want to get c by itself, I'm going to start by minusing 32 on both sides. So it's going to go away. So I'm still going to have 9/5 c. And on this side, I can't actually get a number for f minus 32. It's just the expression f minus 32. Can't do anything with it. All right, I'm really close here to having c by itself. I just need to eliminate this fraction. We just talked about, well, how do you get rid of a coefficient that's a fraction? You're going to multiply by the reciprocal, so 5/9, because you're going to end up with the same answer on the top and the bottom, which simplifies to just a 1c. So I need to multiply this entire side over here by 5/9. So since I want to multiply everything on this side by 5/9, I'm going to go ahead and throw this in parentheses so that I don't forget. And if you wanted to distribute it here, you could, but you don't have to. In this case, there is nothing wrong with just leaving your answer like this. Technically, you could distribute it, but then you're going to get somewhat of a goofy number of a big fraction looking thing over here. So let's just leave it like this. C has been isolated. We've solved for C. You'll notice this is the Fahrenheit to Celsius conversion equation. So if I'm solving for Fahrenheit given Celsius, then this is what I want. Plug in Celsius, multiply, add, and now I have Fahrenheit. But what if I want to know what Celsius is when I'm given Fahrenheit? If I plugged into this first one, now I've got to do some algebra to get the answer. Whereas in this now equation that's solving for C, if I'm given Fahrenheit, I'm just going to take that Fahrenheit minus 32 times by 5/9, and C equals that number. So it kind of just depends on what you're given and what you're looking for, which equation is better. But these are equivalent to each other. They both will work for the same pairs of numbers. All right, so last one, example number 5. If you're feeling really good about this, or you want to test yourself, pause the video and try example number 5, and then follow along with me and see how you did. Okay, so I'm going to start working through this. I'm trying to solve for h, so h needs to be by itself. It's being multiplied by two things. It's being multiplied by 1/2. It's also being multiplied by this quantity, b1 plus b2. All right, 1/2 base 1 plus base 2 times the height. This is the formula for the area of a trapezoid. So I want to solve for h. So what if I'm given area and I'm given the bases and I want to know what h is? It's a lot nicer if this equation is already solved for h. It says h equals, plug in for everything, and I quickly get my answer. So I want to get h by itself. So being multiplied by the quantity, base 1 plus base 2, also being multiplied by the 1/2. Since I'm trying to get rid of h and I have this fraction that's a coefficient that's being multiplied, I'm going to start by getting rid of that. So multiply by the reciprocal. And that will eliminate the fraction because you're going to get 2 over 2, which is just 1. So these go away. So let's talk about what's on the right side. The fractions canceled. So I still have base 1 plus base 2 in parentheses, so the quantity, times h. And on this side, 2 over 1 is just like 2. So it's 2a. All right, I almost have h by itself. It's just being multiplied by this quantity. So this is just this times this. So pretend this is just a number, 3 times h. I divide by 3. This quantity times h. Well, I'm going to divide by the quantity, base 1 plus base 2. Since it's on the top and the bottom of the fraction, it cancels itself out, leaving me just h. And there's no math that I can do over here. I'm just leaving it as 2a over base 1 plus base 2. You can leave the parentheses there. You don't have to. We already know that whenever we have one of these fractions like this, you solve for the whole bottom, you solve for the whole top. So the parentheses are unnecessary. We don't need them there to tell us to solve for the whole bottom. It's already given. But you can leave them and it's just fine to have the parentheses in your denominator.